Hello and welcome to this prismatic machining video. In the previous video I showed you how to go about setting up or assembling your part, stock, and fixture elements, if you have those, as input to your process file. In this video I'm going to quickly show you how to reuse existing templates of product, stock, and fixtures that have been set up that you can use to modify and get yourself ready. So we've created a few of these which can be found in the course folder. So I'm going to go ahead and open up one of these. So I'm going to go to File, Open, and I'm going to go to the desktop, and I'm going to navigate through the MFG332 shortcut to the course materials, and then finally into the CATIA training files. Under Prismatic Example 1, if you come down here to the bottom, there are two products, one called VF2-S1-prismatic_1, which is the first setup for use of this particular example on the VF2 milling machine. And then there's one for the second setup. So I'm going to go ahead and open up the first one. And this shows you already a part, the Prismatic 1 part, the stock, vise, and a few other elements. There is this shows you the work table of the VF2 milling machine, and there's also a work envelope which is currently hidden. So if you go into the work envelope body by expanding, you will see that the part body down here is currently hidden. If you unhide this, what it does is it shows you the work envelope of the Haas VF2 machine. So this is the envelope in which the gauge point on the spindle can move. Also shown here is an axis system, and that axis system is the home position of the Haas VF2 machine. So the home position is where the machine goes to do tool changes. It's the position that the axes of the machine default to when the machine is first turned on. So again, this is more FYI. It gives you an idea of the envelope where you can actually move the tool to do machining. I'm going to hide this. So if you wanted to, you can reuse this template, which would save you having to build this entirely from scratch. Of course, the geometry that you might be machining, the part geometry and the stock, could be very different. So you would have to replace these. So what you should do is you should go to File, Save Management. So under the File menu, Save Management. And what you should do is locate this file here. So it's called VF2-S1. This is the one we opened, and you should save it from the course folder to a place that is secure for you. So I'm going to just navigate temporarily to my downloads folder, and I'm going to just go ahead and create a new folder just temporarily to copy this into. So I'm going to go in here. So I'm going to save this product there. And then, if you recall, you've probably done this already, propagate directory will go through the assembly structure and save everything else that's part of the assembly into that new directory. So this directory I just created, which should be, of course, your own directory. So notice now that the save action applies to all the parts in the tree from the assembly you've picked, and they all go into that same folder. So I'm going to hit OK. So I now have a copy, and it's my own copy. I can modify it, I can edit it. You will not be able to edit the files that are in the course folder. You don't have permissions to do that. So if you try to do that, you'll probably get an error message. But if you make a copy, you're free to do what you want to with it. Now what you would do is you would then go about swapping out the design and the stock. Now there are two ways to do this. It's not always clear which is the easier one or the faster one or the more efficient one. Of course, the first way is to just go ahead and delete your design, delete your stock. Make sure when you delete that, so let me just show you. If I click on delete, there's an option here to delete all children. Well, what does this mean? What does children of this part mean? Well, in the assembly context, children also refers to any constraints that reference this particular design. So if I were to go ahead and delete without this checked off, so I'm going to go ahead and delete it, notice that some of the constraints now have this circle, this exclamation mark inside this yellow circle, and that's because I didn't check off that delete children. The constraint remained, but the constraint is now broken because the part that referenced that constraint, or the part that was referenced by that constraint, is no longer in the assembly. So I'm going to do undo. I'm going to do a Control-Z to undo what I just did. So I brought back the part. Notice that that exclamation mark inside the yellow has disappeared. So if I go ahead and delete this again and check this off this time, so in other words, notice now that the constraints, tree constraints highlight, and these tree constraints are referencing this part. So when I delete this part, those constraints all go away too. So I'm going to hit OK. And then the stock too, I can do the same thing with the stock. So that's one way for you to delete. And then of course you have to add your part back in, add your stock. You've got to constrain them together and then assemble them to the fixture. The other way that you can do it is by using the replace component command. So you can click on replace component, you can say I want to replace the prismatic part, and then you can navigate to the part you want to replace it with. Now when you use replace, you often have to go in and fix constraints because the constraints are no longer connected correctly to the new part that you bring in. So you may find that these constraints are going to be broken and you have to manually fix them too. So as I said at the beginning, it's not clear which is the more efficient way, whether to delete and add and reconstrain or to try to use the replace tool. You're welcome to try either. I found that sometimes one works better than the others depending on how similar the parts are. And other times you buy more work by trying to do the replace. And one last thing, I'm going to cancel this off. If you bring in a part that obviously has a different dimension, if you want to adjust the vise position, the jaw of the vise, you can do this by making sure that you highlight the top level assembly. If you go under Tools Formula, there is a parameter here called jaw spacing that allows you to change the spacing of the jaw to match the stock that you bring in. So in this case it's 6 inches. I'm going to just, to demonstrate, increase it to 7. If I can get this selected, apply it. So now you can see that the jaw has opened up. So you have the ability with this model to readjust this sliding jaw to match the dimension of the stock that you're going to use. So again, this is a way that shows you how to use one of the existing templates to help you get started in setting up your part, stock, and fixture geometry for your process file.